A few days ago, as most of us know, NASA rolled out an announcement, or rather, that they were going to be announcing something on Monday, October 26th at noon Eastern Standard Time. And whatever this something was, it was going to be incredibly exciting. NASA was very cryptic about this announcement, of course, with only two major details having been revealed. Number one, that the announcement would be about the moon, and secondly, that this discovery had something to do with the SoFIA, which is a 2.5-meter telescope, an infrared telescope rather, that is carried aboard a 747 at high altitude. And when it's used to observe objects like the moon, it's usually used to determine composition, indicating that there was something about the moon's composition that we didn't know that was now about to be announced. For my part, I hope that we had found a lot more water ice besides just what we suspected existed at the moon's south pole in places like Shackleton Crater, that there was a lot more water ice that we could use for oxygen, for hydrogen fuel, for liquid oxygen fuel, things that would be useful for just about every type of ship that's going to be used to explore the solar system, including, of course, the Starship. And it would be much easier to get to low Earth orbit than launching it off the Earth, encouraging us to establish a large human presence on the moon. But there are many other theories. I had a live stream about this very event, and many theories were put forward, like perhaps there's a lot more metallic elements, other things that we can make use of on the moon. Or perhaps we found methane or large carbon deposits which would allow us to make methalox fuel on the moon, something that's confounded Starship fans from the beginning when it comes to this particular destination, and many other theories. And so finally, yesterday, the announcement was rolled out, kind of amateurishly really, and as you're about to see from the remarks that I made yesterday, I wasn't very impressed, and neither was much of anybody else. But today, after having a chance to sleep on it, I decided to take another look. Was all of this just hype? Or is there a practical use for this discovery that was made by the SoFIA? Well, we're going to find all of that out in just a few minutes. Hello, and welcome to a special episode of the Angry Astronaut, sort of an abbreviated episode based on the announcement that was recently made by NASA at about noon today, although sort of in a chaotic fashion. I actually had to go to another source in order to get a hold of the live stream. I don't know if the rest of you experienced that, but it was a bit frustrating. Actually, a number of things about it were a bit frustrating. However, in terms of what the announcement actually was, most people that I have talked about have been somewhat disappointed about it, at least in terms of its practical applications. However, in terms of pure scientific value, there is a lot from this announcement that we did not expect, and that is namely the existence of water on the surface of the moon exposed to sunlight, something that we thought was completely impossible. Now, we're not talking about a lot of water here. The estimate was 12 ounces per cubic meter is what was talked about, so not a lot of water, but nevertheless something that could serve for a practical purpose for some limited applications for man's return to the moon. a lot of applications that it's not going to be useful for, but still some things that it could be useful for. And also just purely in terms of scientific value, it is quite amazing. And their explanation, at least in terms of how this water got there and why it didn't evaporate as it should have, is in itself kind of fascinating. So get ready for a special edition of the Angry Astronaut, thrown together as quickly as I could for your benefit, but nevertheless, I think you're going to find it pretty interesting. So hang on. Okay, so I lied. This video is going to be a little bit more involved with that. Let's start with the SoFIA itself. It's essentially a poor man's James Webb telescope, an infrared telescope designed to fly above the vast majority of the Earth's infrared interference. Of course, unlike telescopes on the ground or in space, telescopes on 747s are vulnerable to turbulence, plus the actual compartment that the telescope is in is subjected to high-velocity winds, which creates a number of observational difficulties. Temperature is also a big issue for infrared telescopes, so this thing is cooled prior to takeoff so that the telescope and the surrounding air, once it reaches about 41,000 feet, will be pretty much identical. If you don't have that, it's going to cause problems with infrared images. This is one of the reasons why the James Webb has to be cooled so incredibly, is so that its temperature matches the surrounding space. Once the James Webb is actually launched, this thing is going to become essentially obsolete. One of the reasons that it's been on the chopping block, I think, so many times. Nevertheless, SoFIA has a sophisticated network of gyroscopes and torque motors to make up for the motion of the aircraft and the wind, and has been able to produce some pretty impressive infrared results in the past. Still, I do believe that it is going to be outdated fairly soon. Nevertheless, this time it did produce a pretty interesting result, albeit of questionable practical value. The discovery was made in the Clavius crater, or the Clavius crater, depending on what part of the world you live in, but in any event, this part of the moon gets a hell of a lot of sunlight, and therefore should not have any water. Now, we've known for some time that there's both hydrogen and oxygen in this area, but we always thought that it was hydroxyl, which is a close cousin to water, but not water, but the SoFIA discovered otherwise. Now, as I mentioned before, there isn't much water here. We're talking about a few hundred parts per million, or roughly 12 ounces for every cubic meter, which is drier than the driest desert on Earth. But the point is, the water shouldn't be there at all. We've always thought that sunlight would evaporate water, especially in a vacuum environment, almost immediately, and yet it didn't. So why did this happen? Well, there's a number of different theories, any one of which could be right or wrong, but one theory is that micrometeoroid impacts create enough heat to fuse the ice with surrounding materials, creating little beads which protects the ice from the sunlight. Another theory is that the grains of the lunar regolith produce enough shade to protect tiny bits of ice from sunlight as well. This would make the ice a lot easier to exploit if that was the case. So let's assume that this water is exploitable. How could it be used? I mean, once again, we're not talking about a great deal of water. Well, I gave this a great deal of thought and came up with one idea. A small research outpost like this one proposed by the ESA could actually be supported by the water in the surrounding regolith, assuming that the water's present everywhere on the moon in the same amount as it is where the SoFIA looked. So let's say you had a crew of 2, each requiring 5 liters per day in order to survive. Now, 5 liters is a good average. Women require less, but I would say that that would be a safe average. So you would also require, of course, regolith to cover the dwelling in order to protect it from solar radiation and cosmic rays. Now, if you're going to be gathering up all this regolith anyway, why not design a hybrid device that both gathers the regolith and covers the habitat and processes the water in the regolith to put it into a reservoir for the astronauts when they arrive? Now, assuming you have a 93% recycling efficiency like they do currently on the ISS, it would only require 1 cubic meter of regolith processed per day per astronaut in order to make up for the water lost by the recycling, so they could sustain themselves indefinitely as long as they could process that much regolith. Now, for a long-term outpost, this could become very problematic very fast, because for 2 people, you'd be looking at 700 cubic meters, actually more than that, over the course of an entire year. That's a hell of a pit, or your ISRU system, like this one here, would have to go further and further afield to find the regolith and the water necessary. Then, of course, there also comes the problem of feeding these people. Although you could do it with something like an aquaponics system as pictured here, which involves both water, fish used to fertilize the water, and then rotating plants through the water and essentially recycling the system by means of the fish and the plants, a conservative system built only for 2 people would require 50 gallons worth of water, and would have, at best, 99% efficiency, which means you would lose about half a gallon of water per day. Not a big deal on Earth, but pretty awful on the Moon. It would require another 4 cubic meters per day to replenish the water lost in a system like this, and aeroponics would be just as bad. Now, all of this may sound pretty damn impractical, but remember, before yesterday, we thought that all of this was impossible, that a station other than somewhere on the south pole of the Moon where there was a lot of water ice was simply impossible to maintain any place else on the Moon unless you brought them supplies on a regular basis, kinda like the ISS. Now, that may not be the case. Now, processing all of this regolith just for 2 people may seem pretty stupid, but when you consider what else is in the regolith, it actually becomes a lot less stupid. 43% or so of much of the lunar regolith is made up of oxygen, and if you extract that oxygen by heating it through various processes, you get metal as a byproduct, in some cases things that are quite valuable like titanium. Now, just about any kind of rocket needs liquid oxygen. As a matter of fact, the Starship, fully fueled, requires almost 1,000 tons of it. So deep pits like this would actually start to make a whole lot more sense. Process the regolith first to get the water, and then heat it to get the rest of the raw materials, both metal and oxygen. It could actually be a very profitable enterprise, and anywhere on the Moon, not just the South Pole. So how would all of this work? Well, obviously you set up your infrastructure first, your habitation areas, your digging machines, processors, etc., along with a couple of astronauts, because all of this could be done by robot, but when it comes to heavy diggers and industrial machinery, these tend to break down more often and would probably benefit from a couple of human overseers. Then, once you've accumulated enough liquid oxygen or metals, you have a ship like the Zeus, which transfers the cargo 25 tons at a time from the lunar surface to lunar orbit, and there, waiting in orbit, is a tug based on the top stage of the Vulcan Centaur, also known as ACES, although these days they have a different plan for that particular ship. In any event, this configuration is designed to transfer fuel, and I'm sure you've seen it before in other episodes. It has a sun shield, extra insulation, and can transfer 120 tons worth of fuel to the Starship in low Earth orbit for 1/10 of the delta V. And fear not, Lunar Starship fans, your vessel hasn't been left out of this either. The 100-ton capacity of the Lunar Starship, plus its ability to land, would make it invaluable for setting up a mining facility in the first place. Even if there is only 2 people running it, it would require a large amount of infrastructure and heavy equipment in order to get going in the first place. And as I've mentioned before, the Lunar Starship would be an invaluable refueling tug for methane for vessels that use methalox fuel in lunar orbit. This would, of course, include vessels like the Dynetics Alpaca, as I have mentioned before, which would be an ideal ship to use to scout out new locations to see how suitable they are for mining and long-term human habitation. So in short, this new discovery opens up the entire lunar surface to make our satellite into an economic powerhouse. Oh yes, and lest I forget, adding greenhouses, aquaponics or otherwise to the equation also adds decaying vegetation, therefore nitrogen, making for a safer atmosphere to breathe, less flammable, and of course, eventually, methane as the greenhouses grow. A lot of benefits to having humans in the equation no matter where we set up facilities on the moon. But before we get too excited about this discovery, we have to keep a few things in mind. First of all of these things about the moon were true before we made this discovery. The oxygen and the regolith, the metals, all of that. In addition to that, we don't know how easy it's going to be to extract this water or how widespread it might be. The only thing that's really changed is the fact that now we might be able to put humans, at least in small numbers, on different parts of the moon. But for the moment, we don't even know that. And as you're going to see from my closing remarks, the whole thing might just be a lot of hype. So, although this discovery does indeed have some practical applications, if we're talking about, the water or oxygen perhaps necessary to support a very small scientific installation of some kind, in situ fuel for perhaps a very small lander like the Dynetics lander. However, in my interview with them, linked in the description, they already talked about using oxygen that's bound into the lunar regolith for that sort of thing. So really not even that exciting in terms of, potential use for rocket fuel for smaller landers. But nevertheless, certainly because human beings require water in order to be able to survive, for smaller installations, certainly this could be useful. It would, as you saw in the video, only require, a few square meters worth of regolith, assuming that we can extract the water relatively easily by use of solar energy or something along those lines and recycle that water. We could support, an installation with 2 or 3 people fairly easily. Now, from a scientific standpoint, once again, very exciting. This is something that we thought was impossible, and we're not going to be able to find out more about it until we investigate the situation further. But the cynical part of me is pissed off about this, very pissed off, because it seemed to me that part of this was almost an advertisement for the SoFIA, which has been on the chopping block a number of times in terms of NASA funding. And a lot of emphasis was placed on this during the announcement in terms of SoFIA is the only piece of equipment or the only way that we could have detected this, the only NASA innovation that could have found these things, et cetera, almost as if to justify SoFIA's existence, which, by the way, is important to companies like Boeing. So I have to admit, there is a cynical part of me that is a little pissed and wondering whether or not all of this was rolled out mostly with such fanfare, mostly to justify the existence of SoFIA. Not to say that SoFIA should not exist. I think that, virtually everything NASA uses has some justification, with the possible exclusion of the SLS. But still, there's more people than just me who are thinking this sort of thing, and that hurts NASA's credibility every time they roll out something big, something exciting, something important, and it turns out to be something entirely different. Let's hope that that wasn't their actual motivation, but I don't know if we're ever going to know that for certain. Now, as far as the contest is concerned, we had two winners, and I'm just not without a great deal of fanfare, but just a quick reminder, it's for Angry Astronaut merchandise. This item, the Olympus Mons piece of merch that I have, and also for Mars Base Alpha. And our first winner was Patreon supporter Stephen Kennedy. Congratulations. I think you've already sent me your address, but in any event, as soon as Teespring can get you your award, also, please make sure to email me exactly which item you would like, the Olympus Mons or the Mars Base Alpha. And then in addition, a non-Patreon supporter is Kelly Harold. And once again, I want to make sure that I'm correct about this. Yes, Carrie Harold. Kelly Harold, I apologize, is the winner of the other item. So in any event, I'll be communicating directly with both of you. Congratulations to the two of you. Thank you for playing, and I'm going to have future contests as time rolls on. So until we're actually on the moon and we make discoveries to determine just how difficult it's going to be for us to have a sustained presence there, exactly what new discoveries await us, and what sort of advantages that this satellite of ours is going to give us in terms of exploring the rest of our solar system, I urge all of you to stay angry about space.